Foundrymen Chennai, I extend a warm welcome to each one of you to this technical seminar on savings with application of exothermic and insulating sleeves. We are honored to have with us actually Mr Anirudha Kandekar, Senior Manager Sales and Technical FORACE Speciality Chem Limited actually, as a distinguished speaker for the evening. I request our chapter chairman Mr to do the welcome address to the audience.
Good evening.
It gives me immense pleasure in welcoming you all to this technical seminar organized by the Institute of Indian Foundrymen Chennai chapter here today at IFSR and Chennai chapter office. Today's seminar focuses on exothermic sleeves, a crucial element in foundry production and methoding. As we continuously strive to enhance production efficiency and quality in our processes, discussions on advancement in this domain becomes a more important thing. We are privileged to have with us Mr Anirudha Kandekar, Senior Manager, Sales and Technical for Speciality Chem, who will be leading the session today. We look forward to an engaging and insightful program. A special thanks to Mr Anirudha, who made this event happen. Just a phone call and it was arranged, and a big thanks to him. A special note of gratitude to the management of all the participating companies for deputing their foundry professionals to attending this seminar. Your support is invaluable in fostering knowledge sharing and technical growth within our industry. This session also marks the 47th program of this tenure, a testament to the collective enthusiasm and commitment of our members. We sincerely appreciate your unwavering support throughout the year. Let's make the most of this opportunity, learn, interact, and grow together. Wishing you all a very productive and enriching evening. Thank you. I now invite on stage Mr. P. Sendil Kumar, Vice Chairman, IF Chennai Chapter, to introduce our speaker for the evening.
எல்லோருக்கும் மாலை வணக்கம். Program is going to start. I am pleased to introduce today's speaker, Mr. Anirudha Kandekar, and he has done his bachelor's production and industrial, and then master's MTech manufacturing technology in IIT Kharagpur, and he has got overall about 16 years of experience. He started engineer design and development in Amtech India Limited, Bhiwadi. Then he moved to Kirloskar Ferrous Industries Limited, Solapur, as a senior engineer, research and development. Then assistant manager, design and development for Indian Smelting and Refining Co Limited, Pune. Then moved to Foseco India Limited as an application engineer to taking care of marketing and technology. Then he was operating as a consultant, operation and business development, Ask Engineering and Foundry, Kolhapur. Currently, he is operating as sales and technical senior manager in FORACE Polymers Private Limited. And he has got close to, his resume says he visited almost about 350 foundries and understand the process and developed more than 965 castings. And he helped to first time write for the robust castings in the companies. It's a big thing. I think his resume is very big. At the start of time, I'm not reading out everything. Let us welcome Mr. Anirudha Kandekar. Let us hear from him.
Warm, brief introduction. So I basically belongs to Kolhapur, Maharashtra. Then I moved to, after my graduation, I moved to IIT Kharagpur for masters. Then as you explained, I have almost 16 years of experience in foundries, and especially I gained knowledge in Foseco. So there also I was handling these filter sleeves, methoding simulations, and same part I am handling as a plus additional responsibilities of business development for the FORACE. So today we are going to look after some technical part of the filters and some technical part of the sleeves with some proposals what we have given and the actual trials what we have done. So this is some, you already know about the FORACE, so just a brief introduction. So we have established in 1980s. We are the leading manufacturers of phenolic resin, specialty chemicals, and now recently in 2022 we have started the sleeve manufacturing also. So we have fully automated plants to manufacture resin and coatings. We are exporting to almost 24 countries. So there is always request from the various foundries to save some metal or improve yield. So I have considered only 5% yield, or how we can save 5% to the foundry. So first thing, we can save 5% metal, or we can save 5% of cost. If you save 5% of metal, it will be saving of the metal, producing more and selling more. And if you save the product cost, it will be only will get some extra quantities and additional to the some benefits to the profit. So I have calculated, or for your examples, I have considered a steel foundry who is manufacturing 350 tons per month with average yield of 53%. So if you save 5% of metal, so annually you are going to save 10 lakhs of rupees. And if you save the product cost of 5%, then you will going to save only 2.8, or approximately you can save 3 lakhs of rupees per annum. So overall together it will be around 13 lakhs of rupees we can save. So this is just a brief content about how we are going to proceed. So customized solutions, what we are offering. Then what are the challenges to provide this customized solution. Then same case studies, what we have proposed to customers and what is their outcomes. Then why more, then we'll go to the filtration, technical part of the presentation, it will be filtration. Then why metal filtration, then various types of filtration and how to select the filters and how to design the running system. Then in feeding system also the same way we'll go, like what is a feeding system, what are different types of sleeves, how to select them, and some quality checks what we are performing on the sleeves, and some case studies with the actual customers. So whatever we are offering as a customized solution, it is beneficial for both. It is for OEMs as well as for foundries. If you consider both together, we can reduce the casting, means casting design can be foundry friendly, then design will be friendly to the foundry, then it is a simplified design which will be castable. Because of that, the development time will be reduced. It's similar to the foundry, means for foundry also we can reduce the development time. We can get first time right or max second time right solutions. Also we can save some cost and we will get the maximum yield. So what are the challenges to the methane proposals or customized solutions? The casting design, now there is a trend to make a thinner casting or save some metal in the casting. So OEMs are designing the castings very critically. So thinner wall sections are there. So because of thinner wall section, castings are very difficult to feed. There are more hotspots are coming, so which are very difficult to feed with the conventional systems. So again, the process, the molding machines. So the molding machines are becoming very fast, and the mold box or the pattern where we are going to apply the sleeves or the methoding aids, it is getting difficult. So we are supporting various foundries to apply these products to get it done very fast. So we are supporting the foundries in developing the method, then product application, also as a product problem solving tool like defect reduction or yield improvement, and also we are conducting various training sessions to various foundries. So these are some case studies which I have chosen for this presentation. So this is first case study where we got a task to reduce the fettling or improve the knockoff. So this is the existing practice where they are using a sand riser or sand base and sand layer, which is having a cross section area of 6000 mm square. So what we have done, we have proposed them a neck down sleeves, exothermic neck down sleeves, by which the area has been reduced by almost, you can say, it has been reduced up to 1200 mm square only. So we can easily knock it off, and absolutely there is the castings are moving faster. So this is a second case study where the customers have added some extra metal, or they have increased the wall thickness of the casting so that the casting weight has been increased from 90 kg to 130 kg in one case. In first case, from 90 kg it has been increased to 130 kg. and from 192 kg it has been increased to 0 or to 10 kg. So that much extra weight or extra machine they are doing to get the casting right or get the feeding pattern in a directional solidification type. So we have to do this project and we have suggested them, and you can say we have eliminated all the extra padding or extra wall thickness what they have done, and the castings are okay now. So here also there is a one direct pour case study where customer has given us to optimize the yield. So what we have done, because of the casting weight is higher, we have kept the direct pour sleeve as it is, and we have tried to optimize the base, by which we got around 7% of yield improvement. So this is just a customer is having some problem, or you can say they are using the outside sleeves or outside risers, so they are getting the shrinkage in the casting. This is 2-ton casting, a jaw plate type. So there we have given the sleeves or solutions, and the castings are now okay. In this proposal, this is an application of the angle neck down sleeves, and the customer want to reduce the molding box size. Here also, the customer currently or previous to our proposal, they were using 4 sleeves, and they want to eliminate or ease the application of the sleeves. So instead of 4, we have proposed them only 1 neck down sleeves, and the castings are going okay. In this also, that green color shows the chills, and on top of this they are given 4 number of sleeves with extra pad. So the task has been given to eliminate the chills and to remove the extra pad. So what we have proposed them are central sleeve with that first proposal what we have said now, that with neck down sleeves. So all chills has been eliminated. 18 numbers of chills were there. So in our proposal now there is no chills. So this is also a defect. They were getting some defect under the risers because of wrong selection or wrong placement of the sleeves. So we done the simulations and we have given the proposals, and we have adjusted the location of the sleeves so that the defect and the casting will be fed at the hotspot itself. Here also the task is given to reduce the number of sleeves. So previously they were using around 6 number of sleeves, and with our proposals only 3 numbers of sleeves are given. So this is a shell, you can say a case study for a shell molding. So customers are using direct pour sleeves in a shell. So what they have asked us, they want to eliminate the direct pour sleeves or they want to reduce the sleeve cost. So what we have suggested them a open sleeve with the filter. Some changes we have made in the shell itself. So the cost has been reduced by, that sleeve cost has been reduced by almost 50%. So I will tell something about the filters. So these are the familiar filters across various foundries. These are the pressed or extruded filters. So their working philosophy is like this. So they are having a specific holes, and if the metal or inclusion comes greater than the diameter of the holes, then those inclusions or slags will be trapped on the surface. If it is the inclusions or slag are smaller than the holes, then the slag will go inside. So these are the foam filters. So this is the working principle. So they are having different pores inside the surface. So minor to minor slag or inclusion particles will be get trapped. So here we have done some experiments in comparison with the foam filter and press filters. So we have sent some aerated water, and you can see same aerated water is coming out. But if you see the foam filter, then the clear water, all air bubbles have been trapped in the bubble, in the filter. So flow also you can check. If you say this is the diameter, then almost equal diameter is getting outside. But in foam filter you can say almost a converging type. You can say a foam filter is using all full area of the filter. So to prove this, we have done one plate test kind of thing. In this, in one cavity we have kept foam filter and one extruded of press filter. So we have poured it and then machined it, so, and done a dye penetration test. So in that you can clearly see, as compared to press filter, in foam filter the particles or inclusions levels are very low. So some technical part of the how to select the filters or how to design the running system. So in foam filters, we have special filters for iron, special filters for steel, and special filter for non-ferrous. So in iron filters, basically there are 10 ppi, 20 ppi, 30 ppi, and 40 ppi. Ppi means ports per inch. For grey iron, it is always recommended to use 20 ppi or 30 ppi. For ductile iron, it is always, you can say you can use around 10 ppi, or in some cases you can go for 20 ppi also. And in high resist or CMO grade, you can use 10 ppi filters. So how to calculate the filtration capacity? If you consider a 50 by 50 filter and you are going to pour the grey iron metal from it or CI metal from it, so the filtration capacity will be around 100 kg, or filtration rate will be around 3.5 to 4 kg per centimeter square. So just you have to calculate the area, what 50 into 50 into 3.5 or 4. So that number will give you maximum filtration capacity of the filter. So similarly, you can calculate it for the ductile iron or grey iron. Similar way, it will be for ductile iron, it will be half, around 50 kgs, and for CMO and high resist or aluminum castings, it will be again half, it is around 25 kgs. So this is the chart which has been developed for you. So for one side, this is the filter size, this is the filtration capacity for the HI, this is the filtration capacity for the grey iron, and this is for aluminum or high resist castings. So now how to calculate the running system? So far, any doubts? So basically, we need to fill the casting as quickly as possible, as quietly as possible, and as cleanly as possible. So this is the first step by which you can calculate the pouring time, which is crucial for the designing of the running system. So this is the formula. The simplified version is like that. You can just calculate the bunch weight, multiply it by 2.2 and take the under root of it, and you can adjust within plus or minus around 10% of it, so that you can get a approximate pouring time or required pouring time for the calculations. The next important thing, we need to calculate the choke area. This is the formula for the choke area calculations, which will govern the pouring time. Next part is the head height, or you can say head height required to fill the casting with the pressure. After all these things, you need to decide which type of running system you want to use. It is a pressurized system or non-pressurized system. The difference between both is that in pressurized system, the controlling area, what choke area we have calculated, it will be at the inlets. And these inlets will control the velocities as well as the pouring time of the system. But in non-pressurized system, the area will goes on increasing. The choke area will be at the down screw or very near to the parting line. Then the area is increasing. So after calculating, selecting the pressurized or non-pressurized, you have to select the filter position, how you are going to place the filter, whether it is horizontal, vertical, or at angle, and accordingly you need to select the filter prints. Now some information about the feeding systems as well. So in feeding system we have sleeves, mainly insulating and exothermic. In that we have open sleeves, blind sleeves, neck down sleeves, separate cones are there, direct pour sleeves are there, boards are there, cover leads are there. That I will show you. This all the details I will show you in the next slides. In powder products we are having anti-piping compounds, and also we have a breaker cores for the sleeves. And in methadone solutions you already know, like we can support various foundries in improving the yield, quality, and first time right solutions. So in FORACE we have developed, in exothermic sleeve we have developed 3 grades. The premium grade is 800, then the medium grade is around 400, and the regular grade will be 100. Also in insulating and direct pour sleeves are also available. So these are the open sleeves which we have. We have ready with the 18 up to 18 inch of diameter. In blind sleeves we are ready with the 8 inch of diameter. Direct pour sleeves are also available with us, and neck down sleeves are also available. We are saying you can customize the neck down sleeves or neck or shape whatever you want, or we can provide you the separate neck and the open sleeves. Angle sleeves, what we have already seen in the case study, those are also available. Cover leads, to make a neck down sleeves or open sleeve as a blind, we can provide that also. Boards are also available with us. The main principle or use of the board is like, if you want to feed this thick section from this thin section, generally in steel casting what they will make a metal pad, and after that they will try to remove this metal pad. So instead of metal pad, we can put this insulating boards so that this channel will solidify later, and the metal will feed directly to the hotspot. Various types of breaker cores are also available with us, which will reduce the gas cutting and the grinding work. We just knock it off and we can send the castings. This is the working principle of the, or you can say, of the anti-piping compound. So maximum heat transfer will be from top area. So if it is an open riser, you can put an anti-piping product to restrict that heat loss, so that the riser will remain in a molten condition for longer time. So this is just an example, or you can say, if it is an open riser, sand riser, then it is solidifying in 30 minutes. If you put an open sleeve, then the solidification time is increased. Again, if you apply APC on the sand riser itself, again, if you compare it with regular and this one, the maximum heat loss will be restricted. And if you apply open sleeve with APC, then again you can increase the solidification time. So now in FOSECO we generally do cube test to test our sleeves performance. Periodically we are doing the cube test for all the sleeve sizes whatever we are producing. So our target is to meet around the feed safety margin is around 25% to 30%. So for all cube sizes or all sleeve sizes, we are doing the cube test periodically. For neck down sleeves also, we are doing the cube test. This is the burn test or burning rate. So we are claiming the burning rate around 0.9 to 1.1 mm per second. So this test we have done in front of the customer or on the shop floor of the customer where you want to test the sleeve. Now, how to select the sleeves or how to select the risers? First, you have to decide what type of riser you are going to use, whether it is a sand riser, whether it is an insulating riser, or whether it is an exothermic riser. Or recently, you can say a hot product like high density sleeves. Then you can decide the type of riser, it is open, blind, neck down, or direct pour. Then second step will be you have to calculate the modulus of the casting, or it's better to go for the calculation of the section or the hotspot. Then according to modulus of the casting modulus, you have to increase the modulus or you have to select the greater modulus of the sand riser or the sleeve riser. Then you can get a one size of the sleeve. Then in the next step, you have to calculate the feed metal requirement of the casting. So which will be depending upon the alloy which you are going to pour and the shrinkage percentage of it. So with the available data sheet, this effective modulus, it denotes the sleeve modulus and this denotes the modulus of the sand riser. With the data sheet and with these two sizes, you can select it from the data sheet which riser you have to use. One more thing you can go, if you want to replace the sand riser with the sleeve riser, then you just calculate the sizes, like diameter and height of the sand riser. Go to the data sheet, match that dimension with the data sheet, you will get the modulus. And this modulus you have to find it in this column, or you have to go for the higher side. If it is a 70 diameter and 100 mm height, the sand riser modulus is around 11 mm. Then the same you have to find out in the effective modulus, that is sleeve modulus. Then it is around 12.5. So you can choose the sleeve of 40 by 72 to replace the sand riser of 70 by 100 mm. Then you have to finalize the neck of the risers. Then you have to decide how you are going to apply the sleeves. There are three types by which you can apply the sleeve. First one is inside application into the mold. That after mold has been prepared, you can insert the sleeves. Ram up application, that before molding you can put the sleeves on the pattern and it will be get rammed up in the mold. And the close over method, like you are putting this pores in a mold, like that way you can place the sleeves on the drag pattern and the pattern will get closed. So some field tests what we have done is whatever proposals we have given, according to that we have conducted the field test at the various customers. So these are the case studies or proposals and castings done at the leader walls. These are the after knockoff. The castings are fine. These are again some case studies, whatever we have given the proposal, according to that what we have done actually. So in our railway lines, railway castings also we have successfully used the sleeves. Sorry. So that is the end, and if you have any questions we can discuss.
What are your plans about steel casting or HA?
Both, all. Steel, HA and aluminum also.
Any more questions? One plus you have shown now.
Pardon?
1 inches. How much temperature will you get?
How much temperature?
What is the temperature?
Temperature at least 1 inch. If you are going to conduct it at the lab, this has been conducted on the molten metal platform. So that was a steel casting, a steel grade we have created, and on that the steel has been created. But if you want to produce taste it in the lab, then they will take the hot plate. The temperature of that hot plate will be around 1400 degrees. Then the emission will start.
No, that's right. My question is, when the sleeve is burning, what is the temperature?
Okay.
Liberates the temperature, there will be some.
So what we have tested it is, this temperature has been increased by 150 degrees to 200 degrees.
So it means you mean to say that 1400, you have done the hard plate, right?
Yes.
So it means it will be around 1550 to
1500, it will increase, but in high density it will be more than 200 or 2 degrees.
Different I tested that is, I will measure the temperature of the steel burning.
It's not like high density also plus. Exothermic reaction will happen because of the alumina percentage. It will increase the temperature.
What is the conduction of the sleeve generally?
Generally, it starts from the 15% to 27 or 28% in exothermic sleeves. In high density sleeves, it is more than 30-35%, or it can go up to 40% also.
The burning test you will measure only the time it takes, right?
Starting
1 hour, 10 minutes.
1 mm per second. 1 mm per second. 1.9 to 1.1 or 1.2 mm per second.
If it burns at that rate only, you can correlate with the metal feeding also.
Yes.
So the boiling second could be 20 seconds much. So will it withstand to that extent?
No, it is a cold riser, not a hard riser. We are not cooling to that.
Oh, okay, I know that. Even cold riser also, how much time it will withstand it? That is what you put that.
It will
It is
fall.
very standard.
No, sir, even comes and necessary steel. From that point it starts burning. Normally steels will be at the top only.
It's longer
That
time
is
it will
going to.
Longer the time it will be best.
Yes.
Boiling time should be lesser.
Lesser.
Yes. It should burn fast.
Burn fast. It should burn fast. And so it should conduct that temperature from the aluminum to the metal. So that the hard metal in the riser will be in the molten condition for more time.
Yes.
So that the feeding gets completed. Otherwise the purpose of using steel is
Sleeves should
burn fast.
Yes, sleeves should burn fast.
Burn fast.
Because they are surrounded by the sand. So we are testing it in open condition. So that should burn fast.
Actually, when you see the sleeves will be inside the mold, right? Yeah, we are doing the experiment, it is outside the atmosphere. So be there will be
There will be difference. So that's right.
time will be more. It takes
Time
time
will
to
be
work.
from 1.4 seconds to 1.5 seconds.
50% it will be more.
Definitely, time will increase.
And again, mold when it should be free from moisture. College, you should just Generally, they test it in the resin content this thing, then there will not be moisture. Otherwise, yeah, the moisture which is present in the sand also affects the P56.
Can you differentiate the insulating sleeves and exothermic sleeves? And also its application. Where I have used exothermic, where I have used
Mostly,
all in three.
mostly for Asian casting, it is always recommended to use insulating sleeves. But you can go with the exothermic sleeve with some barrier in between the exothermic sleeve and the casting to avoid the contamination between the sleeves and the casting surface. And for steel casting, it's always better to go for the exothermic sleeves. Because in high density sleeve also you can see there is a compressor core in between the casting and the sleeve, which will act as a barrier. If you put it on the casting itself, you can get a graphite degeneration or graphite pollution because of the reaction between the sleeve and the casting.
Graphite also.
Yes. So that's why always you can see high density sleeves are advised, or you will get a high density sleeve with the better for you.
Insulating sleeves are recommended for bigger dia of risers. Yes, in a bigger size of riser, the molten metal itself will take long time to insulate. So there is no need of any exothermic. So bigger.
Just in terms of MEF, you can say
Generally, it is recommended above 6 inches dia sleeves. It's recommended for insulating 6 inches.
But to save some metal, because if you compare the modulus or MEF, you have to go one size or two size higher in insulating sleeve than the exothermic sleeve. That metal, extra metal will go to compensate the MEF.
When the molten metal itself is going to take more time to get solidified, then there is no need of exothermic. And the cost of the sleeve also, exothermic insulating is almost double.
Not double, around 30% or 20%.
Minimum at least.
But yield will be less. Yield will be getting reduced. Yield will be reduced.
Marketing choke area, what is the weight considered for molding weight or casting weight?
One shade. Total core weight.
Proper core.
Like, you know the casting weight, you know the approximate, if it is the SGI, that's why I told you, it is the approximate pouring time. So, we need to design the pouring system, we need something. So, for that, if it is a CI casting, you can consider yield around 70% for calculation. After that, it will be increase or decrease, or you can optimize it afterwards. So, with the upshot soft flow price. For AGI, you can consider around 60 to 65%. Then you can get a bunch weight, and then you can calculate the choke area as well as the pouring time.
Steam will be at 50% maximum.
It depends upon the casting shape. So, 3 or 4 proposals in which I have personally achieved the yield around 70% on steel casting.
Which type of casting is asking? Where you got above 60% yield?
Shapes I don't know, but it is not a ball casting. It is some
General weaving.
But it specifically depends upon the casting shape, geometry.
What is the application of angle sleeves? So, what is the application where the ability to use?
So this angle we can vary. So if casting surface is in angle, you cannot put the sleeve like this straight, or you need to cut the sleeve, reorient it, and then you can make it vertical. So instead of that, just directly you can put it at an angle. For that only the design has been made.
So in LG question, we have to place next, sir. That junction is angle sleeve. Maybe
No.
profile is very low.
angle and your casting profile need to be matched. Because this angle, if you put it at an angle, it is available in 30 degrees, 45 degrees, 50 degrees. So this angle should be matched with the casting surface. So it's, I have shown you one more this application. So you can buy these separate cones. You can put it at angle whatever you might be. Then cut the open sleeve with the matching angle and then reverse it and you can put. This is a better option. In whatever angle you want, you can place it.
It can be ready-made. You can make it
What change that will? Housing differential plan, there is a profile curve is there. Okay. If there is a neck and put twice there, sometimes the casting gets hard for is 1 inch by 1 inch hard for means we get piping at the neck area, even below. At the junction, we may use this angle.
Yes. Yes, you can use that.
That is right.
Otherwise, you can use this sleeve.
And another one thing, there is a in between out dia and outer wall dia, there is a restriction in the sand thickness. So you may use this.
You can give it also.
Yes. So that the sand get not heated. It's a pretty very good use. Pretty very good use.
Neck down sleeves are generally recommended for only to reduce the
It's better to use breaker cone.
Because
cost is
those days people used to have the pads. It is also made out of exothermic material. Again, that will consume more metal. That is why then the technology changed and this came. Earlier, in fact, everything is avoid the rejection. Because those days, the yield and all was not that matter.
Yield was not there.
So they used to provide a pad below the nice sleeve. Then that will take care of the stick. There will not be any problem for the casting. But then subsequently the competition came and then there was a pressure for increasing the yield.
During FORACE, one case study I have developed for the Bajaj cylinder heads. So in that I have sold only 200 grams. But if you consider the production numbers, so for Bajaj, they got around in savings in crores.
Volume.
Yes, volume is more. So before I have one question. One customer asked me this question: what is the good inlay velocity to fill the casket?
Inlay velocity.
Yes. Or recommended inlet velocity to
good casting.
To not to get the inclusions or not to get the splashes. According to my experience or whatever I have information gathered, I came to know around 1 meter per second.
Per second.
Yes. But I just want to know from
other people.
Yes, whether that is correct or
1.2 per cassette.
1.2.
Per cassette. That is his experience.
Okay.
Local
Local head.
1.2 meter per second.
Any background for it, means any scientific reasons?
you lot of players
Experience. Good experience.
what is actually happening inside the
Inside only. In the simulation only we can be but that is also my answer to that Foundryman. But he said that that is wrong.
The 1 meter per second is wrong.
It's wrong. You have failed.
But how much he was saying?
He was telling 0.5.
Yes, that is not possible.
Yes, that is 0.5 is a laminar velocity. That I know.
That's
For laminar flow. But if you feel the more of the cavity,
not enough. It should be more. You have to increase. He is an experienced foundryman.
yes. From the top.
Oh.
Now I request actually Mr. K. Dayalan, Chairman of National Skill Development Center, to felicitate actually Mr. Anirudha with the honors. I request Mr. K. Varadarajan sir, Governor of Chennai chapter, to felicitate actually Mr. Anirudha with the memento. Thank you, sir. As we have come to the close of this insightful seminar on savings with application of exothermic and insulative sleeves, it's my privilege actually to extend the heartfelt vote of thanks on behalf of Indian Institute of Chennai chapter. First and foremost, a sincere thanks to Mr. Anirudha Kandekar, Senior Manager, Sales and Technical FORACE, Speciality Chem, for being with us and sharing his experience and valuable insights. And thanks to everyone actually for joining us today evening and making the session more interactive. And your presence and engagement made the session truly meaningful. We hope actually today's session has been beneficial, and we look forward to for many more such interactions. Thank you all and have a great evening ahead.